Hello everybody, and welcome to another Pure Arch Linux install tutorial. Today, I'm going to configure an Arch install for laptops with smaller screens, where desktop space is limited. Let's get started. I've chosen i3 as the window manager, the Linux long-term support kernel, and full snapper booting from read-only snapshots to easily recover a broken system. The Arch Install guided installer unfortunately sets the Arch ISO fonts to a very tiny size, too small to read for a 1080p YouTube video. Yes, I've experimented with set font and tried every trick in the book. It's a known issue, and hopefully will be fixed soon. I want to use it anyway to demonstrate a custom file system layout that some of you have requested. The workaround I found is simply using a live ISO based on Pure Arch, not Manjaro by the way. Let's switch over to one such live environment. All the steps I perform here will work perfectly fine on a regular Arch Linux ISO, and it's readily available. You just have to squint at tiny fonts if you go this route on your physical hardware. Also an alternative, you can also use ArcoLinux ISO. Great project. Maybe we'll do a video on that in the future. Fantastic work. That makes so many things available for free on ArcoLinux. Alternatively, you can also use Esnix's Easy Archer project to download one of these ISOs. These are all live graphics ISOs that you can run and run Arch install from one of them. And also work around from the tiny fonts problem. We're using today EndeavourOS and Artemis Nova. And it's very convenient and handy to have anyway for fixing existing Arch installs. XFCE environment is very light. So we're just going to switch to the terminal here. So this is my workaround I found to get readable fonts in Arch install guided installer. So let's install it with sudo pacman-sy arch install, because that's not installed by default in the EndeavourOS live ISO. Okay, so 2.5.2 is latest. It's installed, so let's launch it with sudo arch install. Let it do its thing. And so Arch install language is English, keyboard layout is US, mirror region will be set to, as you can see, this is a short list because of the problem mentioned earlier. So United States. Locale language is ENUS, locale encoding is UTF-8. The drive will be VDA, that's the target drive. The disk layout shall be, we'll select what to do. We'll suggest a partition layout with Btrfs, since it's a rolling release, won't do anything else. Default structure, and compression will be turned on, that's the default. So compress and no data copy on write is all false, so let's fix those. But first we'll like to add a subvolume, an additional subvolume. So set desired subvolumes on the Btrfs partition. Index 1 for the Btrfs partition. And so I'm going to go through this list here. And we're going to add a subvolume because I want to be able to run KVM images on this device. So at images, and the mount point will be var lib libvirt images. So we want also this to be compressed and no data copy on write, because otherwise our QEMU virtual machines will hang. So I like to be able to run KVMs on my systems, as mentioned earlier. All right, so let's fix the compression. We'll for the root or at subvolume, we'll turn on compress. Same for the at home subvolume. We'll select compress. The log subvolume, Same thing. Also the package subvolume. Compression speeds things up and reduces the wear on SSD. Also for snapshots. And images is already set correctly. So this all looks pretty good. So we'll confirm and exit. And here we go. So we got compression turned on all the subvolumes, just like we want. And no data copy on write is true for images so that our KVM QEMU virtual machines don't hang. Right? Don't have to do this if you don't run KVM or QEMU. So save and exit. So that's how it's done with Arch install to configure subvolumes. No encryption password. Bootloader will remain grub install because we want to boot from read-only snapshots. ZRAM swap is set to true. Hostname, instead of Arch Linux, let's put Arch install or AI-i3 because we're using the i3 window manager today. No root password, we want to disable the root account for security. Let's add a user. Steven, of course, is my username. And 123 will be my password for this demo. Not my real password. Yes will be sudo super user. We'll confirm and exit. So I can sudo as Steven. Profile will be desktop, and let's look for i3. So i3 is there. We won't use gaps today. We've got limited screen space, so we won't have gaps. We'll just use the regular i3 window manager. For the graphics driver, you will choose according to your device. We'll use all open source for our KVM. And for audio, we'll select Pipewire, which seems to be the default already. Kernels, I will deselect Linux. I will select Linux long-term support for some of my NVIDIA hardware that has problems on occasion with the latest bleeding edge kernels. Additional packages for i3 and for this demonstration, I'll install Firefox, Git, GNOME Terminal, Ranger for the i3 file manager, text-based, and TTF in Consolata for Your Eyes. I found that's a very nice font for terminals. TrueType font. Okay, network configuration. What I'm going to do is not just GNOME and KDE, but also i3 can use Network Manager and all its utilities as text version utilities, as well as the Network Manager applet for configuring your network. For the time zone, US Pacific. I scroll from the bottom for make it quick. Timesync is true. Multilib for 32-bit library support. We'll include that. And we're ready to install. I'll edit out much of this so that I won't bore you guys too much. So this looks pretty good. Let's hit enter and we're off to the races. So it configures the disk, downloads the packages, installs the packages, and enables the basic services, such as file system trim and network time protocol, etc., etc. So it's done. Magic of video editing, right? Let's chroot into the installed system. Let's see what I did with the file system table here. Cat fstab in Etsy. Yeah, they still have some bugs to work out. I don't think it's fatal to this install, but you've got compress equals z standard and compress equals zlib, both. So I think with the running system, it'll just do the last option, which is compress equals zlib. Relay time, if you've got an SSD, no access time or no A time is what I would recommend to limit wear. But we won't bother with that today. Let's keep this video as short as possible. So, installation completed without any errors. So let's reboot. And there we go. We've got, not EndeavourOS, but a pure Arch Linux install. Linux with the LTS long-term support kernel. 123 is my password. And we'll use the standard i3 session here. This is tiny font again. We'll just hit enter for the generated config. And we'll hit enter to write the config with the Win key as the mod key. So just hit enter twice for this tutorial. And mod enter opens up a terminal, the GNOME terminal in this case. So let's configure some things for this virtual machine. You probably won't have to do this for physical hardware. So we want to echo xft.dpi as 125 pixels, or points, I should say. And we'll redirect that to .x resources in our home directory. Next, we'll export for the GDK GNOME applications the dots per inch scale equal to 1.25. And we'll direct that to .profile in our home directory. Again, for your physical hardware, you probably won't need to do this. But for this demonstration today, I have to do this. So we'll just set the display resolution with xrandr. Our display is virtual-1 for a KVM. And mode will be 1920 by 1080, which is the resolution of this YouTube video. And we'll redirect that to, or send that to rather, .xprofile, also in our home directory. Okay, so let's sudo vim etc default grub. And what I like to do is set the kernel screen resolution. You can do that by adding to the grub command line Linux default line video equals 1920 by 1080. It looks pretty good. So yeah, that'll set the boots screen, the grub bootloader, to 1920 by 1080. So sudo grub -make config -o boot grub grub.cfg, and that'll tell it to update the grub install for the latest Linux kernel command line options that we've modified just now. So sudo vim etc lightdm.conf. We want to configure a display manager for a couple of things. First, we want to make sure that when we're booting read-only snapper snapshots, that we're able to launch LightDM and not get a black screen. So you have to fix that. You have to say user authority in systemdir, set that to true. Whoops, this is actually a comment in the file, so let's undo that damage here. Let me look at the actual option under LightDM section. So user authority in systemdir equals true. If you leave this false, LightDM will not launch when you boot from a snapshot, and that'll make it useless, right? So anyway, another thing under seat, again, you may need to do this on the hardware, on your hardware. But for me, with the virtual machine, I have to set up the display to tell it what my screen resolution is. So display setup script, and I'll put a script in here in etc lightdm monitor-config.sh shell script. And so this file, write and quit, this file is done. So let's create the screen resolution script with vim etc lightdm monitor-config.sh. This is the regular shell script with xrandr, I think. Yeah, so hashbang/bin/sh, and we'll do an xrandr --output as before, virtual-1. And we'll set the mode to 1920 by 1080. And that's all, just a single line in the script. Very handy. Write and quit. Write the file. Let's make this file executable with sudo chmod +x for execute /etc/lightdm/monitor-config.sh. Tab completion would have worked here. All right, so next let's vim/ .config, i3 config, that's in our home directory for our i3 configuration for the window manager. The default Pango monospace font, I'll set that to 12 so you guys can read it better. Again, your hardware may not need this. This is for virtual machine only. So let's reboot. Let's escape and let's boot from the hard drive. Linux LTS, yes. All right, so we've got full screen resolution here. Of course, the fonts are small. Apologize, guys. But it'll be a lot bigger shortly. So let me log in with 123, my super secret special sauce password. There we go. That looks a lot better. Let's make the font a little bigger. Let's fix GNOME Terminal to make it more i3 friendly. Let's turn off the show menu bar by default, save some screen real estate. Let's rename the profile from unnamed to Stephen. And let's turn off terminal bell, custom font. I like to use Inconsolata, 12 points. Use colors from system theme. Now let's do GNOME Dark to spare my eyes, because for my accessibility. Tango as the palette. Show bold text in bright colors. Let's turn off the scroll bar and limit scroll back to whatever memory size you have. So we'll close that here. All right. So let's close the terminal and let's open up some terminals with mod enter. Looks pretty good. All right, we got good screen space usage here. So mod D, the D menu works. On mod 2 for the second workspace, Firefox looks great. So mod 1, mod 2, you can switch between workspaces. Very cool. Mod shift Q closes programs. That all works. So free-h shows we're only using 247 megabytes and no ZRAM swap. The installed system uses 2.3 gigs. You can see 2.3 gigs on all of our BTRFS subvolumes because it's all shared namespace for the root partition. So let's type mount, pipe it to grep home. And as you can see, we've got zlib3, not zstandard, like it advertised earlier. That's okay. I prefer zstandard for reasons, but zlib is fine, I guess, for today. Okay, so sudo vim etc pacman.conf, because we're not quite pure. We still have the EndeavourOS repositories, which won't work in this pure Arch install. So just delete this. And that will make it truly, purely an Arch install. There we go. It'll error out if you leave the EndeavourOS repos in there, because it doesn't have the requirements for running the repos. Okay, so now EndeavourOS is all gone. So let's enable AUR with git clone https://aur.archlinux.org/paru, because Paru is an AUR utility based on Rust that I like a lot. So let's cd to paru build directory and make package-si to build it. All right, so the default Rust. It's supposed to rust up. Rust is great. The latest Linux kernels, not this one, but the latest ones are very Rust compatible. Okay, so let's install it. And it's done. Let's change directory to home. Let's do paru to make sure it works and we're up to date. Looks like we are. So let's remove the build directory. Okay, next, let's paru -S snapper support. And that'll install all of the dependencies that we need for booting from snapshots and snapper and it's all the utilities. Okay, so that will happen here. There we go. can't perform snapshots yet because we haven't configured Snapper yet. So let's do that now. Let's sudo become root, and let's unmount.snapshots from the root directory. Let's remove /.snapshots because when we create with snapper-c root create-config / we create this subvolume. So if you look here with Btrfs subvolume list / you can see we have an extra, in addition to the configured snapshots, we have an extra .snapshots subvolume. So we need to get rid of that. So let's do that now by typing Btrfs subvol delete /.snapshots. And there we go. It should be gone. Let's check this here. Yep. So we just have the as configured .snapshots subvolume, which is configured in file system table. So let's recreate the mount point with makedir /.snapshots, and then using the file system table that we have, mount-a should remount everything. lsblk shows that indeed the Btrfs.snapshots subvolume is back in business. All right. So Btrfs subvol get default for / shows that our defaults is ID5, the whole tree. So we want to have some default to at the root subvolume so we can successfully boot from snapshots, right? So in this case, the at path is ID 257, as you can see. So let's set that to 257 with setdef. And / because we want that default subvolume for root to be 257, right? So there we go. Get default shows now the correct subvolume as the default. Okay, let's clear the screen. Snapper ls shows we have just the current running snapshot. It's not really a snapshot, right? So let's edit the config with vim etc snapper configs root. And let's go ahead and allow the sudo users or wheel group, let's allow them to run Snapper. And also let's change the number cleanup to number limit 10. I'm going along with mostly Arch, the Arch wiki here. So time limit hourly is 5, time limit daily is 5. Everything else will be weekly, monthly, yearly will be 0. Again, change that to your needs. I just based this on the Arch wiki. All right, let's chown the wheel group /.snapshots. All right, so let's exit. Let's become a regular user. And let's do a snapper ls. As you can see, Snapper works with a regular user. Okay, so I think we've got the basic Snapper config working. So let's become root again. And let's change the root directory. Don't have to here, but I just like to do things from root. Systemctl enable -- now grub -btrfs.path. So what this does is it monitors your snapshots and updates grub as needed to boot from snapshots. This is time sensitive. It takes a while sometimes to update. So systemctl enable now snapper timeline.timer for creating hourly snapshots. And so let's update. Let's trigger the grub make config -o boot grub.config. So it shows here no snapshots found, but it ran successfully anyway. And that's to be expected since we haven't created a snapshot yet. So let's do that with our first snapshot with snapper-c root for the root configuration, create -d for description, in quotes, asterisk *** base system configuration ***. That'll show up in our boot menu, or as a boot option, we run grub make config again, and you see it found our snapshot that we just created. It found one snapshot. It'll do this automatically if you give it enough time, but then this video would be super long, so that's why I'm triggering this grub make config all the time. So, Snapper LS, as a regular user, shows we have our first snapshot, number 1, base system configuration. That's always good to have so you can roll back if needed. So let's become root again. Let's create another snapshot, snapper, C, root, create, description. So we're going to create some dangerous conditions here. So we say danger ahead. It won't be, it's just going to be something, if you're cleaning up or whatever, you want to create another snapshot before you do a major system change in case something breaks, right? So you got 2 snapshots ahead. So what I'm going to do to simulate a system breakage, it won't break anything, but I'll do this anyway. I will install a package. Let's pretend that NeoFetch will break the system. So pacman-sy NeoFetch, right? And so what happens is when you install a package, Snapper automatically, as configured, performs a pre-snapshot, number 3, and then does the install, and then does a post-snapshot, number 4. So if you do a Snapper LS, you can see our Pacman operation generated 2 additional snapshots, 3 and 4 respectively, where the post 4 snapshot refers to 3 with the pre-snapshot. So NeoFetch is working, right? It's a great program. It's not going to break our system. This is pretend that we just broke our system, right? So something went wrong. Let's reboot. So we've got additional boot option here, boot menu. You can see a couple of double entries here. Sometimes this happens. It doesn't happen too often, but we just need one of these to boot correctly. So let's boot from the danger ahead snapshot, which will be a read-only snapshot. As you can see, it's read-only. So LightDM works because we did that configuration earlier. All right, so we've got a running system here. So now we can repair the system, right? So let's make the font size a little bigger. Snapper LS. So as you can see, we are running on snapshot number 2. There's a little minus sign there. It's a read-only snapshot called danger ahead. So if, let's see, if I just type NeoFetch, NeoFetch is not available because we're in an earlier timeline with the system. It's great for rolling Linux systems to be able to use Snapper to just roll back. So let's do that now with sudo snapper. Ambit will be classic because this is a root subvolume. And we'll just type rollback. So roll back to our current snapshot, which is 2. So creating read-only snapshot of default subvolume, snapshot 5. Creating read-write snapshot of current subvolume, snapshot 6. Setting the default subvolume to snapshot 6. So we next boot, we'll boot to snapshot 6. So Snapper LS shows you what we have here. And the little plus sign here indicates that's the default subvolume, which will be booting when we next time we restart the system. All right, so writable copy of number 2, which is the danger ahead snapshot. Escape for boot menu. Let's boot from the disk. Arch Linux. And there we go. Our system is fixed, right? Okay, so Snapper LS, as you can see, we're on snapshot 6, which is a writable copy of number 2. Number 2, of course, is the danger ahead snapshot. All right, so let's clear the screen. So NeoFetch is back again because we haven't undone the package operation. You can do that with undo change, which I've shown in my previous Snapper video, if you want to do that. Okay, so I'll let you play with the network manager applet underneath my face. On the bottom right, also the Ranger files manager. The text file manager is great, and other things you'd like to play with i3. But that's it for my demonstration today. I found this setup to be very stable on my hardware, particularly on NVIDIA graphics laptops, where the latest rolling kernel releases can break things. Thanks so much for watching. I hope you found this tutorial useful. If you did, please smash the like button, share with friends, and subscribe if you haven't already. Be well, have lots of fun, and see you next time.